Hi everybody, Johnny here. I hope you're doing great today. You can find more good math at jmathpage.com. Today we're looking at multiplying 3's. And we're going to use something familiar. You've probably seen these before. These are like your 3's tables, and you probably used them in your classroom or you've practiced your 3's with them. But today we're going to be smart about them. We're going to think about them a little differently. So I'm going to think about 3's, multiplying 3's in the tables, 3 different ways. And the first way that we're going to think about our 3's is about addition patterns. We can think about multiplication as a way of adding things again and again. So let's start with that. Let's start with what we know. We know that 1 times 3 equals 3. What we're saying here is we're saying let's have a 3 and add it just one time. If we add only one 3, we get 3, right? But when we look at 2 times 3, we're saying let's add 3 2 times. Well, that's probably easy enough, but we can also look at it this way. 1 times 3 equals 3, so we're going to need another one of these, right? So we're going to need to add another 3. Because 1 times 3 is 3, if we need 2 3's, let's add one more. So 3 and 3 more. Now that will give us 6. Another way of thinking about it is that 2 times 3 is the same as 1 times 3 plus 3 more. And that gave us 6, didn't it? Let's look at 3 times 3. 3 times 3 is going to be 1 more 3 than 2 times 3. Here we only have 2 3's. Here we'll have 3 3's. So we could think about it as 2 times 3 and 3 more. Okay? So 2 times 3 was 6, and we add 3 more. 6 and 3 more will give us 9. 4 times 3 is 1 more 3 than 3 times 3, right? So we can say that. We can say that 4 times 3 is the same thing as 3 times 3 plus 1 more 3. So here's our 3 times 3 equals 9. Let's go ahead and add 1 more 3. 9 plus 3 will give us 12. 5 times 3 is the same as 4 times 3 plus 1 more 3. 4 times 3 plus 3, right? Because it's 1 more 3. Well, we can add that 3. 12 plus 3 equals 15. 6 times 3 is the same as 5 times 3 and 3 more, right? So 5 times 3 and 3 more. So let's go ahead and say 5 times 3 and 3 more. So 15 and 3 more will give us 18. 7 times 3 is the same as 6 times 3 plus another 3, right? 1 more 3. So let's go ahead and add our extra 3. 18 and 3 more gives us 21. 8 times 3 is the same as 7 times 3 and 3 more. Okay, so 21 and 3 more. 21 and 3 more gives us 24. 9 times 3 is the same as 8 times 3 plus 3. You see the pattern? 8 times 3 equals 24. To have 9 times 3, we need our 3 more. 24 and 3 more gives us 27. 10 times 3 is the same as 9 times 3 and 3 more. So let's go ahead and add our 3 more. 27 and 3 more gives us 30. So this is using addition patterns to understand the 3's tables. And you probably just noticed that it's 3 plus 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 3. That's another way of thinking about addition and multiplication together, right? All right, that's interesting, but this will be way more interesting. If we look at the 3's tables and we look at digit patterns instead, we're going to find something very interesting. Let's go ahead and borrow what we learned from our first set of multiples here. So we know that 1 times 3 equals 3, so we can say 1 times 3 equals 3. 2 times 3 equals 6. 3 times 3 equals 9. 4 times 3 equals 12. 5 times 3 equals 15. 6 times 3 equals 18. 7 times 3 equals 21. 8 times 3 equals 24. 9 times 3 equals 27. Whoops, better make it 27, huh? 27. And 10 times 3 equals 30. All right, that's wonderful. We know the pattern now of adding 3 every time. But what about the digit patterns? Well, here, I want you to pay attention to the digit patterns this way. If we look here, we have just 3. So let's write 3 over here. 3 is not being added to anything else. It's the last digit. 2 times 3 is 6. Let's just write 6 here. We can see 3, 6. Let's do the next one as well. 3 times 3 equals 9. Nothing special so far, right? But now it gets very interesting. This is the part to pay attention to. 4 times 3 equals 12. 12 has the digits 1 and 2. So let's write that down. 1 and 2. And what happens if we add the two digits together? 1 and 2 together? 1 and 2 equals 3. Hold on to that, okay? 5 times 3 equals 15. The digits in 15 are 1 in the tens place and 5 in the ones place. Let's write them down. 1 and 5. And we'll add these together too. 1 plus 5 equals 6. Are you noticing anything yet? 6 times 3 equals 18. The digits are 1 and 8. 1 and 8. And we'll add them together. 1 plus 8 equals 9. All right, I bet you see what's going on now. 7 times 3 equals 21. The digits are 2 and 1 in 21, so we'll write that out. 2 and 1. And we'll add them together. 2 plus 1 equals 3. 8 times 3 equals 24. The digits in 24 are 2 and 4. 2 and 4. We add these together and we get, did you know it was going to be this number? 6. What do you think the sum of the digits will be here? 9 times 3 equals 27. The digits are 2 and 7. If we add these together, 2 plus 7 gives us 9. And the last one, 10 times 3 equals 30. The digits in 30 are 3 and 0. 3 plus 0 equals 3. So, I imagine you saw quite plainly that there's a pattern here. We have 3, then 6, and then 9. Now we start again here. 3, and 6, and 9. And then again, 3, then 6, then 9. And you imagine it will continue here. So, one big idea about the digit patterns in 3's is that the sums of the digits for any product multiple of 3's will always be some multiple of 3 itself. Okay? These are all multiples of 3. And that's a special idea. The sums of the digits for any multiple of 3 will always be 3 will always be able to go into it evenly. All right? So you try it out yourself. What are the next two after this one? So that's a special digit pattern for 3's. Let's go to the next one. And this one, let's think about this one as, we'll just call it smart, being smart, okay? And I don't have a better name for it, but if you do use some of these, this is about being smart with multiplication, all right? So right now I'm not going to write down any of the things we know. Let's pretend we don't know any of them right now, and we wanted to start to figure them out on our own. Okay, that sounds good, but I'm going to ask you to focus just on 3 of them to start with. And what I'm going to say, and I want you to think about, is how just these 3 multiples help us figure out any other multiple of 3. The first multiple of 3 that is the key to finding all the other multiples of 3 is 1 times 3. 1 times 3, as you know, equals 3. Okay. The other important one, the second important one, is the 3 times 3. So 3 times 3 we know is 3 plus 3 plus 3, and we know this is 9. We can check what we have before. And one more, 5 times 3. Now we know 5 times 3 is the same as 3 plus 3 plus 3 plus 3 plus 3, or 3 5s, and that gives us 15. If we know just these 3, we can figure out any of the other ones. Let's see how that works. Let's do the easy ones first. We know that 1 times 3 equals 3. We know that 2 times 3 is going to be double that. So we know that 2 times 3 has to be 1 times 3 plus 1 times 3. This one's going to be obvious. But 1 times 3 plus 1 times 3 equals 2 times 3, right? We know that 1 times 3 is 3, plus 1 times 3 is 3. 3 plus 3 equals 6. And so we know 2 times 3 equals 6. But that was probably an easy one. But let's look here. The next one that's pretty easy is 4 times 3. Okay, 4 times 3, we can say 3 plus 3 plus 3 plus 3 plus 3, but we could also say 4 is double 2. So in this one, we'll just double the 2. So we say 2 times 3 equals 6. Okay, so we could say 2 times 3 plus 2 times 3. So we got 6 for the first one, plus 2 times 3 is 6. And these together will give us 4 times 3, or 6 plus 6 equals 12. So we know that 2 times 3 plus 2 times 3 equals 4 times 3, or 6 plus 6 equals 12. So what we've done is we've doubled the 2. So here's the 2. 2 times 3 equals 6, double 6, and what do we get? We get 12. Okay? So those are easy ones so far. We have 2 more easy ones, and then it gets a little tricky. Well, actually 3 more easy ones. Let's do the same rule for this one. How about 6 times 3? Why don't we use our doubling rule again? 6 times 3, we know that 6 is double 3, right? So let's give ourselves a little note here. For this one, we just want to double the 3. What does that look like? Well, 3 was 3 times 3, right? So we could say 3 times 3 plus 3 times 3 is going to give us 6 times 3. What do we know about these? Well, we know that 3 times 3 equals 9. So this is going to be 9 plus 9 equals 6 times 3. So what is 9 plus 9? 9 plus 9 is 18. So we doubled the 9 to give us 18. Okay. Let's do one more easy one. Where's the next double? Oh, we have this double. It's pretty easy. Let's try the 8 times 3. Well, we know that 8 is double 4, right? So 8 is double 4. We'll do the same rule. Here's our rule for this one. Our rule for this one is double the 4. Let's look at the 4. 4 times 3 plus 4 times 3 is equal to 8 times 3. We can see that. 4 and 4 make 8, right? 4 times 3 we learned was 12. And 4 times 3 is 12 again. So we add these together. 12 plus 12 is equal to 8 times 3, or 12 plus 12 is equal to 24. So we can say that 8 times 3 is equal to 24. So we've doubled this one. All right, looks like we have 3 more. Is there one more easy one? There is one more easy one. Do you see it? It's another double, isn't it? 10 times 3. Well, 10 is double 5, isn't it? So our note for this one has to be double the 5. Okay, if we double the 5, we know that 5 times 3 equals 15. So let's write this out. We have 5 times 3 plus 5 times 3 is the same as 10 times 3. Okay, what do we know about 5 times 3? Well, 5 times 3 equals 15, so we can say 15 plus 15 is equal to 10 times 3, but 15 plus 15 also equals 30. So we can say 10 times 3 equals 30. And that's the last of our doubles, isn't it? We've saved the last, most difficult ones for last. Let's see about them. Let's look at 7 times 3 right now. I'm going to think about 7 times 3 in a very different way. I'm going to think about 7 times 3 as 3 times 3 plus 4 times 3, because 7 is the same as 3 plus 4. So let me write that out. I'm going to say that 3 times 3 plus 4 times 3 is equal to 7 times 3. All right? What is 3 times 3? Well, 3 times 3 was 9, and 4 times 3 was 12. So we add these together. 9 plus 12 is equal to 7 times 3. 9 plus 12 is equal to 21. So we can say 7 times 3 equals 21. That was trickier. But can we use the same rule for the 9s? Do you remember how I broke up the 7 into parts? Into 3 and 4? Well, we can do the same with 9, can't we? This time let's use 4 and 5. So we can say 9 times 3 is the same as 4 times 3 plus 5 times 3. And that's the same thing as 9 times 3. Okay? 4 times 3 was 12, and 5 times 3 was 15, and that equals 9 times 3. Well, 12 plus 15 equals 27. So we can say 9 times 3 equals 27, right? Okay. Now, if we go back, we used just 3 multiples to figure out all the other ones. 1 times 3, 3 times 3, and 5 times 3. 1 times 3 told us about 2 times 3. 2 times 3 told us about 4 times 3. 6 times 3 was understood through 3 times 3. So all of these helped us to understand all of the multiples. So I've shown you 3 different ways to think about multiplying 3's. The first was through addition patterns. The second was through digit patterns, the last digits. That was very interesting, wasn't it? And then the last one was just being smart, ways to break apart the numbers to figure out what the multiples should be. I do hope this was helpful to you.